How to gold plate a hunting knife. This video is for educational purposes only. Please experiment responsibly. Electroplating is a fascinating skill in that with knowledge, proper technique, and practice, you can manipulate matter itself. Like Midas, everything you touch can turn to gold. But unlike Midas, you can also plate conductive objects with many other metals, like copper, silver, zinc, nickel, tin, brass, and chrome. Even some metals you've likely never heard of, like palladium, rhodium, and ruthenium. Electroplating confers the characteristics of those metals onto the object, like making them conductive, like copper, corrosion-resistant, like zinc, or aesthetically pleasing, like gold. It opens the door to countless opportunities in industry and everyday life. Not to mention, it's immensely satisfying. Today we'll go over what electroplating is, how it works, and he'll give some practical methods on how to successfully do it at home. Chapter 1. What is electroplating? Electroplating, also known as electrodeposition, is the process of bonding one metal onto another through carefully controlled electrolysis. Now in English, it's the coating of one metal onto another metal by using an electrical current. It is used in countless industries to give a finished metal product resistance to rust, wear and tear, better conductivity, or for aesthetic reasons, such as plating gold on jewelry. There are two primary methods for electroplating that are accessible to your typical hobbyist: brush plating and bath plating. Brush plating is excellent for small-scale electroplating work like plating jewelry, finished knives, or on objects that could be damaged if placed in a bath full of harsh chemicals. Bath plating is ideal for larger objects, objects with complex shapes, and for industrial finishing of metal, like chrome plating. So now that you know the basics, let's go over how it works. Chapter 2. The science of electrodeposition. A plating bath is like a big battery. It needs a positively charged anode, a negatively charged cathode, a power supply, and a conductive liquid electrolyte. The anode is typically a pure piece of the metal you're applying, so if you're plating copper on a piece, you'd use a copper anode. In bath plating, the sacrificial anode is slowly dissolved in the bath over time, replacing the metal that is plated out onto the workpiece. An inert, unreactive anode can also be used, which will efficiently deposit the metal onto the workpiece, except without replenishing the bath. Inert anodes include stainless steel, titanium, platinized titanium, graphite, lead dioxide, and mixed metal oxides. It is generally best to use an anode of the same metal you are plating, but where that is impractical, like gold plating, an inert anode is preferred. The cathode is the workpiece you would like to plate on. Note that each type of metal and alloy reacts differently, and you'll need to adjust your process depending on the metal you are plating on. Some metals are not possible to plate on through hobbyist means, like titanium. Some are challenging and require numerous steps, like stainless steel and aluminum. Copper and nickel are very easy to plate onto other metals, and they're easy to plate over, which is why they are often used as undercoats before plating pickier metals like gold. The electrolyte typically contains dissolved metal salts like sulfates and chlorides, plus various additives that boost conductivity, brighten metal deposits, prevent etching, etc. Let me know in the comments if you'd like a video on how to make your own plating solutions, and I'll share my personal recipes. So, are you ready to start plating? Not quite. First, you need to pre-treat your workpiece to remove all the crud and oils, then activate the surface for successful adhesion. Chapter 3. Pre-treatment. The first and most important step is to properly clean your workpiece. I mean spotless, straight from the factory clean. If you half-ass this step, you're guaranteed to have problems. A variety of methods are used, often beginning with sand blasting to remove any surface crud, then sanding to get down to the shiny bare metal, then polishing to get a mirror-like finish. We'll then need to do an electrocleaning in an alkaline bath to remove any oils, polish, or grease from the workpiece. Make sure to wear gloves so you don't get skin oils on your piece. Also for safety, since all of these solutions contain acid, caustic chemicals, and toxic soluble metals. Some professional solutions even contain cyanide. Yikes. Let's see how the knife is coming along and go over the steps in the process while we're at it. Once your workpiece is factory clean, you can proceed with the following steps. Step 1. Clean with distilled water to remove any loose debris. Step 2. Electrocleaning to remove oil residues. Step 3. Then another rinse in distilled water to remove the electrocleaning solution. Step 4. Then we immerse it in an acid bath to dissolve any surface oxides. Step 5. Plate with a nickel stripe. This provides a foundation upon which the rest of the metals can adhere. Step 6. Next, we add a bright nickel plate. This adds a polished sheen that will help bring out the full beauty of the gold. Keep on plating the nickel until you have a uniform, thick coat. Notice the change in color as the nickel adheres to the blade. Step 7. Another rinse. Step 8. Now we apply the gold plate. Building up a nice thick coating is essential for getting an attractive and durable finish. It's starting to look really good. Just a few more finishing touches and we're done. Now I'll go over some tips and tricks on how to electroplate like a pro at home. I recommend taking notes. These tips will shorten your learning curve considerably. Chapter 4. Practical tips for brush plating. Tip 1. Electrocleaning. After electrocleaning, you'll know your workpiece is ready once water no longer beads on it, but sheets off all at once. This critical detail can make or break a plating project. Notice how water droplets collect on this wrench. It looks clean, but it has oils on it that will prevent successful plating. Here it is again after a 30-second electrocleaning. Much better, but it's not quite there yet. After another minute of electro-cleaning, the water sheets right off, with no water droplets collecting anywhere on the wrench. Now it's clean enough to be plated. Tip 2. Metal surface activation. The acid dip activates the surface of the metal by dissolving any metal oxides formed by exposure to oxygen. You can't plate over oxidation. This can be especially tricky with metals like nickel and aluminum, as this oxide layer forms almost instantaneously on exposure to air. Strike solutions are used to solve this problem by dissolving the oxides in the bath, while plating a thin layer of the desired metal on the surface to prevent reoxidation. Use dilute hydrochloric muriatic acid for activating nickel or steel, and dilute sulfuric acid for everything else. Do not acid dip prior to using any cyanide-based plating solution without an extremely thorough rinse. Acid plus cyanide, das hydrogen cyanide gas, which is extremely lethal. Unfortunately, cyanide makes some of the most effective plating solutions available, so it's often used for metals that are difficult to plate, like gold and silver. Professional plating shops often keep a cyano kit, cyanide poisoning treatment kit, in case of accidents, composed of medicines like amyl nitrate, sodium thiosulfate, and vitamin B12. These are an effective frontline treatment for cyanide poisoning when administered by medical professionals. Amyl nitrate is an inhalant, and sodium thiosulfate plus B12 are typically taken intravenously, though in an emergency taking them orally is better than nothing. Talk to your doctor before taking any medication. Tip 3. Electric current. Set up your power supply by plugging the red plus wire into the anode, which is your brush plating pen. The black wire clamps on your workpiece, the cathode, using alligator clips. This way, the current will travel from the anode pin through the electrolyte soaked in the wool tip. The metal ions are then reduced back to metal on the surface of the cathode. The voltage, current, needed varies depending on the composition of your solution and the metal you are plating. Jot this down, this'll come in handy. Tip 4. Good habits. Bath plating requires more stringent control over variables like current, heating the baths to specific temperatures, specific pH, air agitation, a specific anode to cathode ratio, etc. You'll typically find the instructions for each solution on the label when purchased from a professional supplier. Before and after each step, from start to finish, you wash your workpiece with water, brush on the acid dip in a 3 oz or so area, then another rinse, then start plating. If you try to plate areas that are too large at once, it'll dry and reoxidize the surface, causing the plating to fail and flake off. You'll then have to strip off all of the plating, a real pain in the neck, and redo it. So don't get greedy. The proper brushing technique is to soak the tip in the solution, then brush the activated area in a circular motion at the correct voltage until the desired coating is achieved. Tip 5. Undercoats. Gold plating on stainless steel is challenging and requires numerous steps. It is an alloy containing chromium, which doesn't like to cooperate and resists bonding with most metals. To properly activate stainless steel for plating, I replace the sulfuric acid dip with a hydrochloric acid dip, followed immediately by a nickel strike. The nickel strike solution is high in chlorides, which keeps the surface active while applying a very thin coat of matte nickel. Once we have our undercoat, we can follow it up with a regular sulfate-based bright nickel plate, which gives us a shiny and thick undercoat for our gold plate. Gold over nickel has an almost silvery gold hue to it, which is quite attractive. You can also add a copper plate over the nickel, followed by another nickel plate over the copper to really give the gold a rich, beautiful appearance. If you plate gold directly over copper, the copper will oxidize over time, turning the gold an unpleasant green. So plating a nickel layer between the copper and gold prevents the copper from leaching into the gold, which preserves its beauty. For example, the piece on the right has a nickel-copper-nickel undercoat. The piece on the left has just a nickel undercoat. I didn't want to make this video too long, so I left out the copper coat. These tips are only the tip of the iceberg, so feel free to leave a comment if you need advice on any of this. I'm always happy to help a fellow student of the craft. Now for a quick wipe down. And voila, a 24-karat gold-plated hunting knife. Thanks for watching. If you enjoyed this video or learned something new, please like and subscribe. See you next time.